My pleasure to introduce, hang on, your name is not even there, Graham, who's going to talk a little bit about the work that's going on at Macy's. Just for people might remember, if you've been getting emails, Macy's is signed on as a quote-unquote partner with us in the Machine Learning Center, because, and you'll hear a little bit about why, as to the kinds of stuff they do is relevant to us. Graham, of course, is a alum at from Georgia Tech. He was a electrical engineering bachelor's.
That's right.
2000-ish?
Yes, around that.
So he's coming back, welcome back. After that, he went on and finished his PhD at Columbia. On a lot of, in fact, one of his advisor is somebody I went to grad school with, Dan Ellis, who I've known for a while. He's currently a senior vice president at Macy's, and he's going to tell us about a whole lot of kind of stuff that's going on. Pay attention, and if you find any other interesting things that you want to engage with, either reach out to Graham or one of us. We have about 4 or 5 people from Macy's also coming in today, hanging out with us, because we're trying to get this relationship off the ground. But again, as I said, if you find something interesting you want to engage with, find us, talk about it. Also, Macy's is a company that's also looking for interns. And one of their offices is actually close by, but they have offices across the nation doing these kinds of things. With that, thank you for coming. I'm going to get out here. One thing is, I have to leave a little bit at 1 o'clock for a PhD defense, but make sure to keep him engaged until...
Okay, thank you so much for the introduction, and we're so grateful for the opportunity to be here and chat with you guys about some of the things that we're working on at Macy's. Please feel free to have this be much more of a dialogue. If there are things you'd like to stop and talk in more detail about, we're glad to do that. So anyway, we wanted to start off by just giving a little bit of perspective. And so obviously we work in the retail industry, and the retail industry is going through some relatively significant changes right now. And so that's great. We're really excited about that. But we know that competition is intensifying, and there are non-traditional sources for that competition. We know that pricing is becoming more transparent, and that people are able to see what different products are offered for on different sites. We're very well aware of all of the different breadth of assortment options and all the things that, from a personalization or sort of uniqueness perspective, that are becoming available to folks. And so what's happening in the retail industry more broadly is that things are changing, and consumer expectations about what it means to interact with a retailer or a brand are changing. And so we're spending a lot of time thinking about how do we respond to those consumer changes. And one of the ways in which we're investing a great deal is in analytics or data science or machine learning, signal processing, those sort of things, more broadly speaking. Well, I'll sort of talk about them collectively, but sort of mean them all together. And so we really believe within the organization that this is going to be an emphasis for us, and it's going to be a point of differentiation. And so what we wanted to share with you guys today was sort of an overview of some of the things that are going on in the retail space, and that we're working on from a data science, machine learning perspective at Macy's. And so, frequently when we're giving these sort of introductory talks, we get a question of like, well, gosh, I didn't realize that there were so many, but is there a potential for application of these sort of principles in the retail space? And the reality is that there are a great deal. And obviously I'm not going to take you through each one of those things, but basically every single functional area has some aspect that insights or better information are going to change or disrupt in some way. And from our perspective, it's really not a matter of like, are they going to be disrupted? It's a matter of to what extent and when. And so basically what we're doing is relatively systematically going through almost every single functional area within the organization and saying, how do we start to pull that apart and get a better perspective of how we could use information to make better decisions, to improve our processes, and in the future to automate some of the things that have traditionally been done by people. And so we're going to share some of those things with you today. While there are many, many applications, we're going to focus on 3 specific types of examples, and I'm glad to offline tell you more about some of the other spaces. But we're going to focus specifically on 3 different problems today. One related to inventory, one related to pricing, and a third related to customer. So let's start off by talking about the inventory and supply chain. So here is a baseline graph of distribution of demand for Macy's.com. And so this is sort of the foundation. And so obviously you can see that since we're a national retailer, that the demand relatively is relatively similar to the population distribution for the company. And so if we consider like one of the most straightforward inventory management logistics problems that we have to think about, one of the things that is actually a little bit unique about the Macy's business is that the vast majority of things that we sell have a very short life cycle. And so where some of our competitors are selling products that live in the assortment for dozens of years, most of what we sell has a life cycle that's like 6 months or less. And so in almost every case, we're trying to predict demand for items where we don't have any observed history of demand for that. We're going to sell it for a finite period of time, and then we're never going to sell that product again. And so what we're trying to do is figure out how much to buy for those, how to allocate that inventory at various points in the network in order to make efficient decisions and make it a better customer experience. And so the most straightforward problem that we have to think about is, given a demand distribution like we have here and a set of facilities that serve that demand distribution, how do we allocate inventory across that? And so this is a relatively straightforward problem. It's relatively well solved from a linear optimization perspective. And so essentially what you look for is like, where are the different volumes of demand by different areas of the country, and allocate inventory in relationships to that. That works really well. The only constraints the optimization is really subject to is the physical inventory capacity, the throughput capacity. But one of the things that I think people overlook quite a lot is the breadth of assortment capacity. And so in most of these buildings, there's a finite number of like physical spaces that can be filled with. So basically each product needs a unique address in each building. And so what we have to figure out is, how do we allocate inventory to these different buildings subject to certain constraints. And so the biggest constraint ends up being that the assortment breadth tends to be much, much larger than the capacity of any given building. And so what this essentially means is we're trying to sell more products than any building can hold from a breadth perspective. At specific times in the year, there are also depth and unit volume and throughput capacity perspectives. But what makes this an interesting problem from an optimization perspective is really turns out to be the breadth discussion. And so what we end up seeing is that when we're trying to figure out what products to assort into different buildings, what ends up happening most frequently is that, when you ask somebody what goes into the cost equation for how much does it cost to fulfill an item for an order that we capture on Macys.com to a customer's home or something like that, people tend to think about things like the distance that it has to travel or the weight that the package has. But actually the principal component on the cost is actually the number of packages that we have to send out. And so we spend a lot of time thinking about, how do we identify the right stocking of distribution centers to make sure that they've got the most appropriate inventory that's going to be able to satisfy demand and get as many units as possible into a box. That's really ends up being the primary constraint. And so what we end up saying is that this is obviously a similarity matrix, but the axes are different areas of the business, and it's looking for co-occurrence of different products within a particular purchase. And so essentially, the solution to this problem turns out to be sort of this unraveling of this matrix to say, where do we find the products that are most frequently ordered together, and how do we then put them in the same location so that we can have a more efficient distribution to the customers? So that's something that's relatively exciting. But so far, we've only talked about Macys.com and the fact that we have a set of distribution centers to solve that demand. And that's a big enough problem on its own. If Macys.com were its own company, it would be one of the largest retailers in the United States. But obviously we have more to it, right? And so where historically all of the demand for Macys.com would have been fulfilled by this set of distribution centers, the reality is that right now we treat all of our stores and many of our vendor partners as distribution options, right? And so what makes this problem much more interesting is that rather than just saying, how do we optimize inventory across, let's call it 10 different distribution centers, we've got thousands of locations that we're trying to figure out the appropriate optimization of inventory for. And so we spend a lot of time thinking about this, and from a combinatorial perspective, this becomes a much more challenging problem. And so this is really, yeah.
How dynamic is this problem? Because
Yeah, there is certainly variability within the network on particular days. The majority of the products, the demand for the product is small enough that you're really looking at a longer time period. Um, Actually, one of the things we'll talk about just in a second is like how do we balance some of that demand intraday, and I think that's one of the most compelling things that we've done from an optimization perspective. Before we get there, the complicated problem then is, given that we've got literally thousands of locations and millions of different products that we're offering and unit depth behind all of those, how do we assort each one of those different locations, and how do we appropriately allocate inventory to those different locations? And so that's really the problem that we're looking after. And as an organization, what we have done is forward deploy a lot more inventory than just from those distribution centers. And so we actually use our stores to fulfill a great deal of orders, both direct to consumer as well as consumers coming into the stores in order to pick up stuff and walk away with it. The volume that we're doing in terms of what we would call like this alternative fulfillment is like relatively staggering. Again, the alternative fulfillment volume that we're doing here is bigger than most retailers, like period. And so now the problem is, how do we allocate inventory to these different locations, given that we're going to use them for walk-in store traffic, that we're going to use them as fulfillment centers, that we're going to use them as, in some cases, people ordering something online with the intention of picking it up in store. And what we find is that there's this very, very strong relationship between our ability to offer products to be picked up or be fulfilled from specific locations and the rate at which that happens, essentially. And so if we look at a metric of what we would call something like congruency, where if you look at the online demand for particular products in particular locations within a market and the availability of that inventory in a local store, that's a very strong correlate or predictor to the penetration with which we see people ordering something online and then picking it up in the store. And this becomes very powerful for us in that, firstly, if you look at the cost savings perspective, we don't have to actually send out a package and people come to the store, pick it up. The most important thing of this is that we actually see this behavior where when people come into the store, there's a radiation of the sales, right? People actually buy something else. And so we measure something like a 25% uplift in terms of when people are buying something online, coming into the store, then they spend another 25% or so, and that's really exciting, because not only have we saved on the shipping, but we also get incremental sales as a result of this, and so it's something that we're really excited about. And so, well, I think from a customer experience perspective, one of the things that we're trying to do is say, like, that's, if you look at grocery stores in the past, they would put the milk and the bread in the back, so you had to walk through the whole grocery store. And I think people are valuing convenience so much more that there's sort of this trade-off, which is to say that, like, how do we really think about customer lifetime value? And so in many cases, what we're actually doing is trying to make this experience much more seamless and bringing that location to the front of the store to make it easier, with the intention that, like, while we might lose on some of the radiated sales, we trade for customer lifetime value. And we'll talk more about that in just a second as well. Okay, so now the problem becomes, like, how do we actually assort inventory to very local specific stores? And so there's some really interesting work going on in sort of like non-parametric choice models. There's a guy at MIT named Vivek Farias that's done some really interesting work in this space. But what we've been able to find is that where the non-parametric choice models are basically looking at all pairwise combinations and saying, like, what's the information that I can glean by using all of the different pairwise comparisons. What we found is that there's a very close approximation that we can get in a linear space that lets us look at the demand for Macys.com versus what is available and being purchased in the store. And by comparing those two, we can essentially solve the non-parametric problem in a linear space and remarkably closely approximate it. And so in this particular example, this is like the distribution of how high heels sell in the United States as just like one illustrative example. And so the blue represents shorter heels, red represents higher heels. And so you can see that in general, people in the South wear higher heels than people in the North. But but this is one of those things where if you look at like the average, it's like less interesting, right? The more compelling part of this is actually the distribution within each market. And so if you look at places like Southern Florida, then like over half of our sales come in like ultra high heels, where basically like it is a very, very skewed distribution there. But if you look at places like New York, well, it's sort of like one of the middle shades here. It's a bimodal distribution. And so what we see is that people are either buying like flats or they're buying super high heels. And you know, this is sort of just like an entertaining example that we use because you know, people can sort of relate to it. But the reality is we can do this for anything. We can do this for brands. We can do it for product attributes. We can do it for price points. We can do it for sizes. And so what we're doing is using this omni-channel information to figure out how do we forward deploy inventory with the intent that that inventory is going to be able to be used for online fulfillment, for store pickup. And so we're really excited about this because it's this like hack solution, but gets us to a very close approximation of like a very elegant approach. So, yeah.
How many SKUs do you deal with?
Yeah, millions. So, and really that's what we're sort of banking on in this particular case, which is the disparity between what we offer online and what is available in any given store is it's much, much larger online, right? And so that's what enables us to do this like approximation of the pairwise comparison, which is that in the pairwise comparison, what you're getting to is really this way that lets you, through all of the pairwise comparisons, see all of the different combinations, but because you've got almost the entire universe available online, then you can solve for it linearly. And so so the online has, you know, depending on the store, 5 to 20 times as many items available, essentially. So, okay, so, yeah.
Do you differentiate between fulfilling demand from new customers and returning customers in your optimization for that?
Not explicitly. No. What did you mean?
Because you want to also attract some new customers, so
Yeah.
probably you want to have different strategies to attract them and retain them. That's what.
Yeah. So one of the things that we've experimented with a little bit, I would like to do much more experimentation on this, is like the impact of a delivery representation, right? And so it's very easy for us on the back end to, within the optimization of the fulfillment logic, to say like, here's what we're solving for. The package needs to arrive within like this period of time. Like we can solve for that very, very easily. But the reality is that like if we do that, then most people won't give us credit for it. Like you have to actually like take credit for it up front, and that's where the real value is in terms of the impact to conversion. And so we've done some experiments where we've taken our best customers and given them like faster delivery, but the reality is that there isn't a lot of benefit from doing that. Like I would estimate, we have not yet tested that there's a lot more benefit from actually moving up the funnel and being able to provide a more clear message on a delivery representation. So.
I thought this question was more about if you have one person that's buying a lot of high heel shoes,
Yeah.
then that kind of skews the distribution because
Oh, sure.
instead of being able to repeat customers versus
Yeah, that we have done, and so so we've spent a lot of time thinking about, from an assortment perspective, what we call them customer migrations, but essentially like what retained customers are buying and what retained customers are buying within specific areas of business versus new customers. And then when customers lapse, what do? When do they buy other brands? Do they leave Macy's entirely? And so we try to use that information, but that really informs some of our merchandising and marketing strategies. So yeah, we're using that. Okay, so we've made some progress on how do we forward deploy some of the inventory. The next real step is about how do we think about like what we would call sort of the air traffic control for this. And so this is something that, again, we're really excited about, but from a fulfillment logic perspective, we've spent a lot of time thinking about like how do we actually optimize the order that we're taking, right? And so what is boring when you only have 10 or so distribution centers is figuring out what is the most efficient distribution center to fulfill an order. What's exciting is when you've got like literally thousands of different potential places to fulfill an order, Then in terms of any order, we literally in many cases have billions of combinations of like how we could fulfill that order to the customer. And so one of the like really elegant solutions that has happened here is figuring out how do we actually perform that optimization. And so essentially what we do is think about like what is the cost of fulfillment to the customer within a constrained period of time. And we consider different like portions of the cost, whether it's the handling cost of picking and packing the item or the shipping cost of getting it from the set of locations that are purchased, that we're delivering from to the set of locations that the customer's receiving it. The other thing that we've spent a lot of time doing, and we'll talk just a bit and talk about in just a bit, is the integration of what we call like inventory management, supply chain, and some of our merchandising and pricing decisions. And so so the first thing that we do is essentially look at like what is the minimum cost way to fulfill an order. The second thing is figure out like, okay, well, given a cost tolerance, what are the set of potential options that we could also consider? And then within that, say, okay, we can apply some specific business rules to tune how we actually want to shape some of the demand. And so, Irfan, to your question earlier, one of the ways that we can actually do this is by using a tuning mechanism, and so we can do things like actually balance the utilization of all of the different resources we have relatively evenly, or we can specifically bias like certain locations in order to say like, we think we have surplus inventory in a particular location, we want to send more demand there. And so this is something that
How actively can you do this? I mean, let's say a hurricane is coming and everything.
Yep.
You guys probably don't have direct relevance to hurricanes, but other stores have you start saying is get more water out or whatever.
Yeah, I mean, we manage this quite frequently. In fact, I wouldn't say that we make major changes on a daily basis, but certainly if there's a store that has been affected by like a natural disaster or something like that, it's like very trivial for us to turn that off or to point demand away from or to a location. And so, and really where we see the most benefit for this is like in the time frame that's coming up for us, which is getting ready for holiday, which is that we have a great deal of demand that we need to fulfill. There is a relatively limited capacity, and so if you trade off the investment of like, should we build more facilities to satisfy this demand, or how do we become more efficient as an organization in using the resources that we have, we found that this enables us to sort of steer the demand much more effectively. And so this is something that we've introduced in the last couple of years. It actually builds on a foundation of an earlier collaboration that had happened between Macy's and Georgia Tech, but this is sort of the like 3.0 version of the algorithm. So, okay, so that's the quick section on inventory and supply chain. Yeah, sure.
How do you operationalize this?
What do you mean?
Well, how do you add it into the whole supply chain? I mean, do you have demand planners, at your city in the school, or
Yeah,
how does it get into the fabric of the business?
yes. So one of the things that we've done at Macy's is take some very select businesses and sort of move them into being run essentially by more of the like data science folks. And so this is an example of that, where from an operations perspective, firstly, we have the opportunity or the ability to like run scenarios or replays on an ongoing basis. So like while we've got current settings, we're continually optimizing it, right? And so that's one thing. From a management of the system perspective, there's sort of this close partnership between the analytics data science team and the team that actually like pushes the buttons literally of like how to implement this. But all of this is fundamentally dependent on like where we place the inventory in the beginning. And so there's a strong partnership essentially between the design intent of how we want to use the network and the guidance that we provide to the operations merchandising teams of like what to buy or for specific locations and how much of it to buy and where to put it and when to put it there. So those kinds of things in retail 20 years ago, like nobody would have done, but now it's sort of status quo for us. So, okay. So that's it on the inventory and supply chain. The second like quick overview is on pricing. And so when we talk about pricing in a retail environment, most people talk about sort of three things. One is dynamic pricing, the second is promotion optimization, and third is markdown optimization. From a dynamic pricing perspective, we're not going to talk about it because it's really, frankly, not that interesting, right? Like basically, you're looking at what your competitors are doing, and then from a strategic perspective, deciding to what extent you want to match that price or not. And so it's a semi-solved problem. I think from a computer science perspective, it's more of a like pain in the neck that like you have to like keep fixing your algorithms essentially. From a promotion optimization, I'm not going to talk about this because there's like quite a lot of academic literature on this, and really essentially what that's saying is that like if you've got a product that's in the assortment for a long enough period of time, there are times when you can change the price for that either by like reducing the price or offering a discount or offering different like combinations of things like buy one get one and that kind of stuff, where essentially what you're trying to do is increase the demand of units you're selling based on a discount, right? And so there's quite a lot of attention that's paid to this, and so we wanted to spend more time talking about Markdown optimization because we don't view that as a solved problem. And so again, you have to recall that from an assortment perspective, Macy's, most of the stuff that we're selling has a finite life cycle, which means it has like a relatively prescribed start date and end date to that life cycle, and there's a relatively clear understanding of like how much we need to sell and by when. And so, sorry that one of the people on the team put this together, and so we ended up with a dog on the slide, but I'll explain that in a minute. So essentially what we're doing from a Markdown optimization perspective is looking at some expectation of sales for a particular product, right? And so the interesting thing from a signal processing perspective is that this essentially becomes an autoregressive model. You're basically trying to figure out like what does the time series look like for that particular product. Again, remember we've never sold this product before, so it's based on this idea that we're able to find something that is similar enough to this item, and so there's actually quite a lot of work that goes into how do you identify this item belongs to this class of products, and then essentially what you're doing is applying an autoregressive model to say here's what the time series ought to look like. And so then the next thing is really saying, okay, given this, I've got an expectation of what I'm supposed to sell from for each point in time, and what you can do with that is create this cumulative distribution essentially of like what you need to sell over time. And basically what we look for there is given this expected cumulative sales that we need to achieve, in this particular case, if we are performing not as well, then essentially what we need to do is figure out what action do we need to take in order to change the trajectory of sales for that item to sell through to a certain percentage by a certain date. And so the way in which we do that is by fitting different price elasticity curves to different items. And so again, this is something that you end up, I know we've just shown one here, but what we end up doing is providing distributions of that. And so essentially what we're trying to figure out is like confidence intervals over which if I take this particular discount, what is the increase in rate of sale that we're going to observe? And so in this case, the item isn't selling as well as we want, and it's a dog. And so we needed to increase the rate of sale there. So for us, this is really exciting because I forgot to mention this at the beginning, but the three topics we're talking about like literally represent billions of dollars of investments for us as an organization. And so again, the pricing decisions that we make represent billions of dollars for us on a day in and day out basis. And so making just minor improvements in the way in which we price has like relatively profound bottom line impact for us as an organization. So I mean, we can measure the benefits of this program in the hundreds of millions of dollars. It's a really exciting sort of thing.
This could be done very efficiently, let's say, online.
Yeah.
How does it kind of get to what the physical store is?
Yeah, so the most complex thing here is that someone literally has to go out and change the price of the item on the floor, and so it's this imperfect thing. And so from a data perspective, we end up with very noisy data on this because we know in the system that we have recommended that a markdown has been taken, but we only have certain confidence that it actually has been taken, right? And so what we end up seeing is that, like, from an anomaly detection perspective, is that we can actually see, like, okay, we expected this lift, we didn't observe it, and then we can sort of tell the stores, hey, we need to go check on that. I think some of that problem goes away in the future as we get more digital signage, and so that's something that we're very interested in as an organization, not just from a accuracy perspective, but obviously there are huge labor implications for us as well.
You mentioned short life cycle of the
Yeah.
product. Is it only being used there?
Yeah, I mean, we have different techniques from a pricing perspective that we apply to different types of products. This Markdown optimization that we use is really primarily focused on these like short life cycle products. So,
And have you looked at the seasonal effect of it? Like now I expect
yeah,
5% discount on this,
yeah,
so I'll wait until you get there. So then next year,
yeah.
you kind of have a feedback effect from year to year.
Yeah, that certainly exists, and as an organization, Macy's is a very promotional company. In fact, it's one of the things that from a pricing strategy perspective, we're sort of correcting to some extent, but there are certain behaviors that have been trained and we'll actually talk about this from a customer segmentation perspective in just a minute, but there is certainly some element of like consumers waiting for a particular holiday or date to, and this one doesn't really show as profoundly as many, but like this is approximately when there's like some event and so in this particular case, while we're trying to like filter out the promotional effects from an autoaggressive perspective, it like hasn't entirely filtered it out in this particular case. So, cool. So what is exciting about this then is that if we know that this item is behind, and we have some estimation of the elasticity curve, then we can also apply both of those things to say we can project when we would need to take a markdown for that particular item. So we can get a very accurate estimate of the expected value of that item going forward. And so one of the things that makes this much more challenging is that like all of the sort of 101 literature from an economics perspective sort of assumes that you can make continuous pricing decisions, and the reality is that we cannot, right? And so there are very either discrete price points or discrete discounting points that are sort of acceptable to a customer, especially in a store environment. There are lots of folks that are experimenting with like almost a continuous discounting from a pricing or discount perspective, but the results end up being like very strange in some respects to a customer. And so what we're able to do then is to say, okay, given what we've observed so far, given our estimation of the elasticity for this particular item, what is the expected value of that item in each selling location going forward? And using that information, we can say that there's more appealing scenarios to fulfill from different locations given the expected value of the merchandise. And so if you recall back to the fulfillment logic conversation from just a few moments ago, we're valuing based on the different objective costs of fulfillment, but we can also integrate this change in expected value as a function to drive an improved profitability for the organization. And the complexity here is actually an organizational one, in that what we're doing is we're trading operating expense for operating margin, and that's like two different groups of people and two different budgets. And so one of the things that is sort of fun to deal with in a more practical setting is like managing that sort of relationship, but nonetheless balancing it helps us as a company be more profitable. Okay, so that's what I was going to chat about for pricing. The last is on customer, and so as an organization, historically, and a lot of organizations do this, they talk about things like the sort of summary statistics of their customer behaviors, and so you hear a lot of quotes about things like the average spend per customer or the number of visits per customer, and the reality is, and I'm sure you guys know this better than anyone, is that those summary statistics aren't really helpful, frankly. And so we have, and we still, like if you read our press releases, talk about it a great deal, but we spend a lot more time thinking about like how do we create classifications. And so when we start to think about our customers, then the first thing you can do is sort of this like high level segmentation, right? And so this is like a very simple tree classifier that, from an information theory perspective, is essentially trying to, at each cut, divide up the space of customers, either in terms of count of customers or spend per customer, essentially. And so, so what we can end up with is like very straightforward, like understanding of high-level customer behaviors as an organization. And you know, I think one of the things that is kind of funny is that I would bet most of you would assume that like almost all retailers sort of have this, right? And the reality is that most don't, right? Like this level of like customer segmentation is like sort of like already putting you in the top decile of sort of ability to analyze customer behaviors. But the other thing is that when you're analyzing customer behaviors, the reality is that like in most cases you have so little information, it's such sparse data that you need some prior distribution to help inform any of the other models that you have going forward. And so there's some elegance in the end of like understanding what is some baseline customer segmentation. And so for us, there's a huge impact. So you asked a question about like how people have been trained to shop for different discounts. Like we observe that, right? And so we have some customers that view Macy's as a fashion authority and they come to buy the newest releases of certain items. And there are other customers who say, okay, well, I'm willing to wait a few months for those things to go on sale. And then there are some customers who, for them, Macy's is a completely aspirational experience, and they're willing to wait until something is on a very deep discount. And so we're able to understand that and start to use that to inform some of our customer decisions. And so that approach can be applied in a number of different ways. And so if we start to look at the transition of customer behavior from those different states, essentially what you end up with is this mark-off process of like how customers are transitioning over time. And so this is how those customers like move between those particular states. But the beauty in this is you start to be able to have a customer lifetime value prediction, which is this like forward-looking mark-off process view of our customer franchise. And so again, this segmentation on its own is like a relatively simple task. There's actually some art to it, but the beauty in it is that by developing that, you end up with a customer lifetime value measure that enables you to inform a number of strategic decisions. And so at this point, from an organizational perspective, when we're considering almost anything about like a major investment, it comes back to like, how is it going to affect these different segments of customers and the forward-looking view of their lifetime value. And so that can be done at like, obviously the highest level of the organization, but it can be done for like any level of the organization. And so here's sort of that same exercise for a particular area of business. I think this one is cosmetics specifically, but in this particular case, what we're looking at is like the very specific cosmetics behavior. It's the same sort of classification exercise. And
Curious about
yeah,
something.
yeah.
I mean, right now you have that customer segmentation.
Yeah.
And you use it to, of course, provide them with more suitable information.
Yeah.
What would happen if you actually expose that label to the user, saying,
Yeah.
"Well, you just return more than you buy"?
You know, in some respects we do. And so from a corporate strategy perspective, one of the things that we've done at Macy's is actually integrate analytics and strategy, right? So I'm in charge of both of them at this point. And so this customer segmentation that we're doing here, it became the early phases of what is now our loyalty program. And so the top few segments are our platinum customers. The segments right below that are gold customers. And so we have a very like straightforward customer-facing view of this. Now, of course, you know, return dominating customers, then you know, we talked earlier about some anomaly detection, fraud detection, and things like that. Part of the reason that's an issue is we want to be able to have an awareness of those things, and not all of it's nefarious, right? From a customer perspective, we'd like to be able to know if we're not satisfying that demand, so we can develop more efficient merchandising, brand experiences, and that kind of stuff. So this is an example, but we have these for many, many different areas of the business. And so we just wanted to show like one particular thing. And so this is oh, sorry.
Sorry. Do you think you need to update that segmentation table over time?
Yeah, we do. One of the things that we found is that the classifier of like how do we put people into different buckets is relatively stable. and actually the metrics, the summary statistics of the people that are within different buckets is relatively stable. What is dynamic is the count of customers in each one of the buckets, and that's why it ends up being such a good predictor of lifetime value. Is that we can essentially look at the count of customers in each one of those things, and so that's a very high level view of the lifetime value. What I'm going to mention right now is that what we have moved to is much more of an individual lifetime value estimation, and there's some really interesting work that has gone on, like most notably at like Wharton on customer lifetime value estimates. Like almost all of it's based on this idea of like recency, frequency, monetary value. But I think some of those models they're sort of designed when there's a relatively static or uniform demand over the course of the season. What we end up seeing is that there's almost this like gravitational effect of different points in time that like in the same way like gravity warps time, that like here there's this like density of like particular portions of the year that warp the time on like a frequency perspective. And so what we end up seeing is that those models are like insufficient for the type of products that we're selling, because there's so much there's such a seasonality to the underlying demand, where those models work very well for things like subscriptions, where you're getting basically a count of people on a monthly basis. An example of this is this is for like replenishable cosmetics products. So if you think about something like foundation or skincare or something like that, and if you look at different groups of customers and look at the distribution with which they come back, so like what is the distribution around different periodicities for their particular customer behavior, that you can see sort of the top quartile of folks have a periodicity of about 90 days, where the like second quartile of folks have a periodicity of about like 120 days. And some of this is like sort of smooth, but and then what we end up seeing is that beyond that, it really becomes noisy. We're sort of fitting curves to patterns that are not there. But when we start to think about this, really this becomes not only the estimate for lifetime value and how we can predict to what extent someone is going to come back, because historically we would look at the count of customers and measure that on an annual basis. Now we're able to say like, oh gosh, we expected this person to come back in 90 days. It's been 110 days. We should have an updated view of their value that they're going to contribute to the organization. And so not only can we do that from a strategic perspective, but we also use this for dynamic content creation, essentially. And so when we think about things like how do we personalize the experience that different people have, whether it's interacting with an email or the website, then basically there is some overall formula for what an email or the website looks like. But essentially there's a set of potential options that could be shown to every person at this point. And so essentially what's happening is that there are models behind the scenes that are saying, given some of the things that I just described about specific behaviors, specific affinities to things like areas of business or messages or discounts, we can essentially send everyone in the room the same email, but many people would get very different versions of that based on the information that they have shared with us through their interaction with us in the past. And some of that is manifesting itself in the website, and I think from a signal processing perspective and sort of the computer vision perspective that's really compelling is that so that on the website right now, this is a live thing. Not only are we using all the things that I just described, but we've started to integrate visual features into the recommendation as well. And so now there's this little button under many of the products that says more like this, and if you click on it, then well, hopefully I'm still connected to the network. It shows you similar items, and this similarity in this particular case is defined based on sort of the abstract definitions that we're using within our taxonomy, but also visual cues in terms of, in this particular case, you can see sort of the dress length is a very prominent feature in this, and I think if we go back there, oh well. So So you can see that from a visual perspective, we're able to like cue on things like the length of the dress, the colors of the dress, that kind of stuff. And so there's become like part of the feature vector essentially that we're using to define similarity for products. And so all of this, like, I don't know, I think this is sort of interesting. The reality is that like this is like the first early steps of where we sort of think the industry is going, right? And so you know, we're proud of the work that has happened over the last few years, but if you think about sort of like what happens in the future, then like our perspective is that like the way in which people shop today just won't be the same in the future, right? And so you're already seeing elements of this from a voice search perspective or from a visual search or query by things like image. And so what we're investing in right now are these capabilities with the intent that like we don't think people are going to shop the same way in a few years. You know, we used to talk about these things as like very futuristic things, but I think it's only a few years out in terms of how people are going to be interacting with us as an organization. And so we're investing in a number of different functional areas. And what's beautiful is that we have some of these examples where we had built these like abstract building blocks of signal processing or machine learning, like pricing or like fulfillment logic. And now we're at a point where we're starting to like put them together. And so it's sort of this assembly of these different component parts. And anyway, we're really excited about where the retail industry is going. So, yeah.
What do you use for the image sort of similarity?
Yeah, so I mean, there's a number of features, right? So firstly, there's some element of like what the attributes of the products are, and so some of that is like manually developed, right? We're actually able to define here are the characteristics that, given if you look at the left-hand navigation of the website, there are different filters that you can apply. And the other is we've developed a set of image processing features essentially that look at, you know, the standard things like color, but then also things that are very specific to particular areas of business, like the shape of dresses and the attributes that we're learning there. It's yeah. I wish I could tell you more about that, but I'm not going to. Okay, so. Yeah. Well,
I guess this whole thing is pretty astonishing to me in that could you give me some little backstory on how Macy's is such a big company, right?
Yeah.
There are a bunch of different departments, and this is very much a data-driven, operation-research, computational approach
Yeah.
to solving all problems in the business.
Yep.
So from a culture perspective, like, how do you get everybody on board with
Yeah.
this? You know,
Yeah.
like, you guys have done it, right? And I know it's just the beginning, but it's like you have to weigh the entire culture has to be around continuous
Yeah.
improvement.
Yeah.
So how'd y'all do that?
Yeah, so I think the first thing, and in fact the most important foundational element, is that it has to start with the leadership, right? Our CEO and president have talked very publicly about how this is one of the things that we're betting on from an organizational perspective. And so it's really easy to be able to point to like press headlines and say like, look, we said we're going to do this, we're actually going to do it, right? That's the foundation. And then if you have the leadership buy-in, then usually funding follows that. So you end up with the money to actually support hiring people that have backgrounds like the folks in this room and the computational capabilities that we need to actually do this stuff, right? And so that's sort of the first two checks. The organizational change, that's much more difficult. And the way that we've approached this is, I think historically, and even in the popular press, there's sort of this representation that it's like either analytics or traditional merchandisers or traditional retailers, and that's just not how we think. We think that this is an evolutionary process, and that we try to think about like what are the different talents that people have, and how can we augment that with signal processing and machine learning, essentially. And so, what we've done is, you know, go to people really initially helping them, right? And so it's like, here's information that helps you make a better decision in your role. And most people are pretty amenable to that. And so when we go and do that, what we end up doing is this like very iterative approach, which is to say like, here's this thing, it's our idea of how it could be a little bit better. get feedback then, which is that like, okay, this is great, but you haven't considered these particular things. And in some cases it makes the algorithm better. In some cases we need to challenge the original way of thinking. But either way, we're getting better as an organization. Then like typically there's sort of this like prototype or like quick win sort of phase where we take an area of business and just do it a new way. And the idea coming out of that is that like not only are we learning, but before we invest in anything from a long-term perspective, we're able to like actually understand what should the long-term solution look like. But along the way, we're getting buy-in from the organization. They're a part of the process. Like everyone's excited about it. And then finally, there's like you hope that coming out of that, there's some financial result as well that you can say like, look, this is performing better than other areas. And we've been fortunate enough that in many cases that's been the case. And then finally, like once you have those things, like an example of it working well, leadership support, a system in place that makes people's lives easier, then that's the last step is actually pretty easy. And in fact, like it typically goes where people are like very resistant to an idea to like almost overnight like want to adopt it with like too much fervor. And so it's like initially like gaining enthusiasm and then later like sort of dampening it. And it's something we're working on. We don't always get it right, but it is the most complicated. Like we tell our team and we talk internally quite a lot that the math is sort of like the easy part of our job. The hard part is communicating to people that they need to change their behavior, because that's really the business that we're in, is like getting a traditional retailer to do stuff differently.
So did you guys take your analytics team, however big it was, and try to go to every area, like identify low-hanging fruit, just go to every area, or did you really focus on one part of the business,
Yeah.
show everybody that it succeed?
Yeah, it was more the latter, but the how we chose that was not an accident, right? And if you think about the things that like I'm somewhat nervous about everyone taking pictures that they were taking pictures today, but like the thing that I'm not nervous about is saying that the things that we worked on were inventory, pricing, and our customer, because it's not just for us. Like if you look at the balance sheet for any retailer, those are the three biggest investments that they have as an organization. And so like if you spend any time doing sort of like analysis of where's the biggest potential opportunity, then those are the first three things you're going to work on. And you almost always start with like the inventory decisions and the supply chain decisions, because not only is there a huge dollar value associated with it, but there's some amenability already that like people have operations research backgrounds and they're used to applying sort of those analytical approaches to make better decisions. So.
How many years did it take for you guys to get to this point?
I've been with the company for almost 5 years. Yeah. Cool.
So how do you deal with trigger items? What I mean by that is items which eventually have the potential of boosting sales or attracting customers.
Yeah. So if you go back to the pricing. That's really like the dynamic pricing space. And so what we think about is what you calling trigger items, we call key value items essentially. And so those items disproportionately create a pricing perception for the brand. And they do things like drive traffic, drive sales. In many cases, people use them to pull in new customers. The first thing that we've been able to study from a customer perspective is that like the customers that buy those items aren't really necessarily valuable customers. And so in many cases, you're sort of buying sales that aren't worth a lot from a lifetime value perspective. The second thing is that if you think about some of the like larger retailers in the space, like Amazon or Walmart, they're great companies. We have a great deal of respect for them. But a lot of what they're selling has either been commoditized or is at a price point where people are doing like specific research. The reality is that from most of what we're selling isn't a commodity product, right? And so what we do when we're thinking about this like dynamic pricing idea is really start to think about like what are the items that are going to disproportionately create a perception, and how do we use those to do something very strategic. This, in my opinion, it's not a compelling strategy in most cases actually, but there are certain cases where it has a much more profound effect, and we try to leverage that.
So we talked about
Yeah, so it's much more complicated because like every merchant will tell you that their product is the one that that is driving all of the other sales, and it's just not true. So you end up with some like very funny like things from a data analysis perspective because each item can be claimed by many items, right? Because if you look at a particular basket, there are more than one unit in a basket. And then if you look at like the life of a customer and people who bought this over a longer period of time, then they purchase many, many other items as well. And so what you end up with is this like credit function where if you summed up the sales of all of the associated sales with every given product, then it like sums up to way more than your sales as a company. And so what we end up thinking about is like what is like a relative ranking of those, and so yes, we have a very clean understanding of like how different products are contributing to overall enterprise value, but it's a lot different than like how people had thought about it in the past.
Do you have a similar kind of like voice or table about like this customer, this item is the one I imagine
Yeah, exactly. So and so we're talking about some of the key value items and that kind of stuff. Around the holiday time, especially, there are certain folks within the organization who want to offer very deep discounts on certain products, and in some cases they are important to our valuable customers, and in other cases they are not. And so having that understanding has helped us to inform not only merchandising decisions, but like major decisions about should we invest in like additional capacity or that kind of stuff, because we have a much more information about the impact it would have on the organization.
And having these two models, do you run into situations to have like a two-level game theoretic model?
We have not gotten that complicated yet, but no. Yeah.
All the models accurate line estimation. So how, I'm just curious, how do you guys deal with losses? Say if for a certain product, for a certain size,
Yeah.
you got stuff out.
Yeah.
And then do you have a kind of mechanism to track the losses?
Yeah.
To kind of bring up the bias for the management?
Yeah. It sort of all depends on to what extent you believe this model is correct, right? So if you believe this underlying model of what the seasonal demand was for a particular item, then it's relatively straightforward to estimate, like if you had a stock out here, what portion of the sales that you missed, right? And so there is, it's a coarse approximation, but yes, we can, using this as a model, estimate the future demand for products. And so if you think about it, basically there's only two cases, right? Either you have enough inventory on hand and presented to the customer that you're able to measure demand, in which case what you sold is actually your like relatively accurate measure of demand, or you have stocked out as you described, in which case there's sort of two scenarios. One is that you believe that there's relatively limited demand transference, or that there is a great deal of demand transference, and then basically what you're toggling between is like what is the ratio of the season that is still left to be sold, and to what extent you should claim credit for that, given that people might buy something else.
So basically, for example, the first figure, once you get this figure, you just believe that's fixed.
Yeah.
Any comments on David Cincinnati's work?
Yeah, I know who he is.
Is that the airways you were talking about? Is that the guy?
Yeah, I would say that he would have said he does more stuff like this. I would say like Vivek Farias is the one who did stuff that's more like this. He's a friend of mine. I think he's a very talented man. That I think he's doing great research, and I really have a great deal of respect for his company. So, yeah.
They worked on Groupon and Rural Upper.
Yeah, but all of this was really in the pricing space in terms of promotion optimization that was happening. Yeah, he's right.
Since we've lost our original host and
Yeah.
since this is the end of the slot,
Yeah.
we